Hello, welcome to this new class. In this one, solution analysis and post-processing results will be explained. But before the analysis, hitting the solve button, we must take into account a checklist before running the analysis. There are some tips for you to check. First, material properties. Have you assigned properly the material section? Are the units correct? Then the same for load values. The loads were applied in the correct direction. Did you use the correct units as well and values? Have you applied self-weight and in the correct direction, X, Y, or Z? For the mesh, are the nodes connected? Or if they are not connected, have you used contacts or any other connections? You should check if any mechanism will appear. For instance, this is very related to the boundary conditions. Supports and constraints were correctly defined. Have you restrained the degrees of freedom you want? You may have this error, a typical error 2004 for a solver, that it shows because rigid body modes exist. You can correct the duplicated nodes using the merge tool if your model is not correctly supported, so it can fly. And if you have used contacts, you have to check if you perform correctly the contacts, if you have used the correct entities were chosen for the contact pair, and maybe you need to include any other constraint in your boundary condition, any rotation or displacement. If you are defining nonlinear analysis, you must check your solution controls, time step, convergence options. Finally, when you define your load case, check that the boundary condition group and the load group is correctly assigned. If everything goes fine, then we go to next step to check if the results are as expected. Not only that we have a solution, that means that the results are correct. So we always have to some numbers in mind and make simple verification and guarantee that the results match to the expected ones. The typical results that the software will provide are displacements, reactions, stresses, strains, forces and moments. These results can be combined using factors and coefficients, and as well envelop previous results to obtain maximum or minimum or maximum and minimum in absolute value previous results. Besides the structural analysis, later a check and design by code can be performed. New results, criterion, section class, interaction diagrams. It's very interesting as well. Charts, history plot, a transit analysis or a nonlinear analysis, they will be very useful. The results of the load case can be used to customize your results. Those are the derived and user results. Work with the views using clipping planes to obtain more accurate results. And of course you can animate your results. And of course always you can use Python to obtain more powerful tools for post-processing. If we have the software open, one of the typical errors that you might have is this one, error 2004, mark solver, determinant of the stiffness matrix becomes 0 or negative. That's because rigid body modes exist. To correct this, you must check first that you don't have duplicated nodes. You have here to check if you have nodes not connected, a tolerance. For example, all the nodes which are located within this distance, within a millimeter, they will be shown. So I just select all my nodes. If I have duplicated nodes or coincident nodes, don't have them. If that's the case, I can use the merge tool. We don't have, but I can try to merge them. Don't put a very big tolerance because you will merge nodes which you don't want to merge. You have the message that no nodes have been merged. So we don't have duplicated nodes. We must check if we have defined a new material or a generic material. If the material are taken from the library, there should be no problem because the properties were automatically defined. But if you have defined a new material and maybe you have not used the correct units, you must check that. As well, gravity, if it's applied in the correct direction, and if you have defined boundary conditions correctly, check that the displacements are okay, they seem okay. And the last check is see if you have included your boundary conditions in the load case. Here you can see that there are no boundary conditions, so we must add it and check if the rest of, yes, this one has, and this one has as well. So if we solve again, we will get a correct solution. If you are performing a nonlinear analysis, there are many other options that you must check, which you don't usually check if it's a linear static, and which are these ones: step fractions and the tolerance for the convergence and the maximum number of iterations and increments. If we have our solution, we will have automatically our results here available. We have defined 3 load cases using different coefficients for serviceability and ultimate limit states, and using different boundary conditions, because the last one has a imposed displacement in x direction, 3 centimeters if I recall right. So we just select our result file and we can check. You have here the organization of the results, different fields, nodal displacement and rotation, nodal reactions, and then for elements you have stresses and strain and stresses, forces and moments, and other results. So if we click here, we can check the set displacement, and it's very useful that you can select any units regardless the ones you have used in the geometry definition, the cross sections, materials, whatever. And then you have these options to plot average or non-average results, and you have different view options with undeformed shape, with the deformed shape, both, and only deformed shape. As it has a hinge, that's why it has this shape. We can, by default, there's always a scale for the deformed shape, but you can always set your own scale and or set it multiply your deformed shape by a coefficient. The same for the range of values. Automatically, by default, we plot the maximum and minimum values, but you can always set the maximum and minimum here. For example, all the values which are below 0.5, you can do it here, or you can do it by clicking here as well. Click enter, automatically it will be updated. The values out of the range will be plotted in gray. You have more plot settings here. You can change the colors. Instead of having blue as minimum and red and as maximum, it can be reversed. You see here, you can plot it with vectors, and some results can be plotted using vectors. For example, the total displacement. You can see here, and as well include maximum and minimum labels for the result. For reactions as well, you have them, and stresses, strains, forces and moments, axial force if you want. If you want it in the format shape and using a 2D diagram, you have it here. Shear force, if you want to average results, bending moment. You have this option as well for the isosurfaces. You can get information of the analysis, and you can proceed with other further post-processing. We have defined our own combinations using coefficients multiplying each load group, but other way to define those is by defining single load cases, and here include here all the load cases and using here the coefficients you want. Once you create it, then the result will be available here as well, and you can plot the new result. It is shown here. Other option is the definition of envelopes. Obtain an envelope of maximum or minimum results, and you can as well mix them. You can do it. For instance, you want the minimum results in absolute value. Set the title, the name of the new file, and generate the envelope file, and you will have it here. The values of the envelope, you will take the maximum values, and will look for the values of the selected load cases and plot the maximum in absolute value. Another type of results besides envelope and combinations, derived or user results. In this case, what we can do is select result files, or just one, and inside the result file you have all the available results, and if you want to multiply any result, for example I want to multiply it by 2 and create a new file. I will have it here. If I select the new derived result, I will have the value selected multiplied by 2. The rest of them will remain the same. So, thank you very much. Stay tuned and see you in the free course.